In 13.1, this hypothesis test that we'll be conducting is called a one-way analysis of variance. We like to call that ANOVA. Okay, so similar to what we were doing before, we need to set up a null and alternative hypothesis. So in this hypothesis test, this will be the template to set up every ANOVA test. Okay, so given at least 3 different populations, and we'll see an example in a bit, the null hypothesis will be set up as the mean of the first population is equal to the mean of the second population, is equal to the mean of the third, the fourth, the fifth, however many populations we have, but it has to be at least 3 for ANOVA to work. Okay. And for the alternative, if you recall from chapter 10, we were looking for keywords that involved not equal to, less than, or greater than, right? In the ANOVA test, this H1 right here, this will be the form of every alternative hypothesis in this section. At least one population mean is different. Okay, so there's no need to look for keywords when it comes to this section. This is set in stone here for this section here. At least one population mean is different. Okay, so there are some requirements when it comes to calculating or testing the equality of 3 or more means. Okay, so these are the requirements for the one-way ANOVA test. Given these conditions, we can conduct an ANOVA test. So I want to look at example 1 and show you how to conduct a one-way ANOVA test using these steps in the handout right here. Okay, so let's look at step 1. Okay, so step 1, set up the null and the alternative. Okay, so here in the first example, an environmentalist wants to determine if the mean acidity of rain differs among Alaska, Florida, and Texas. Okay, so see, recognize that we have at least 3 populations here, different populations, Alaska, Florida, and Texas. For the year, the environmentalist records the pH level for 4 random days with rain, tests the hypothesis at 5% level of significance. So what we want to test is if the mean acidity is equal for each of these 3 different populations. And that's what the null hypothesis says, that the mean acidity for Alaska is equal to the mean acidity of Florida is equal to the mean acidity of Texas. That's what the null hypothesis says. For the alternative, recall that this will be set in stone for this section. At least one mean is different. Okay, so here again, no need to look for keywords like we did in chapter 10. This will be set in stone here. Now, there is a condition other than the general requirements that we found in the handout here. There is another condition that says ANOVA testing will only work when this inequality is satisfied right here. So when the largest standard deviation is less than 2 times the smallest standard deviation, we can proceed with this ANOVA test. So in the calculator, what we want to do is we want to enter this data set into L1, L2, and L3. So Alaska will take up L1, Florida L2, Texas L3. So we'll go to Stat, Edit, and here I've already entered the pH level for the random days that we collected for each of these populations. Okay, but we'll go ahead and proceed and enter L1, L2, L3. Now, what we need to do is we need to gather the sample standard deviation to see if this inequality is satisfied. So to gather sample statistics, we're going to Stat, Calc, and 1var Stat. Okay, so with the 1var Stat, I'm looking to gather the sample. This is a sample here. Sample statistics, sample standard deviation. So when we're looking to record, here we have the standard deviation for Alaska is equal to 0.24. We'll also take the standard deviation for Florida. So we're going to do Stat, Calc, 1var Stat. This time Florida is in L2. And then we'll calculate. Okay, so notice here we have a sample standard deviation for Florida and that's equal to 0.30. And then finally, we take the standard deviation for Texas, so second mode. And let's do a stat calc, one var stat. Let's do L3. So the sample standard deviation for Texas, so let's do sample standard deviation for Texas. Let's call it 0.31, okay, 0.31. So now that we have these sample standard deviations, we need to make sure that this inequality right here is satisfied. So we need to check that the largest standard deviation is less than or equal to 2 times the smallest standard deviation. So out of the 3 populations, we had that Texas was the largest. We need to see if we are 2 times the smallest, where the smallest was Alaska. So we're going to multiply by 0.24. So this inequality shows 0.31 is less than or equal to 0.48. This inequality does hold true. What this means is we're able to proceed with the ANOVA test. Okay, we're able to proceed with the ANOVA test. So step 3. There are several ways to conduct an ANOVA test as far as evidence goes. If you recall in chapter 10, we had to gather evidence to support our claim. Our claim is the alternative hypothesis that at least one population mean is different. So in this case, we will keep it very similar to before. We're looking to test using p-value method, and we want to see that this p-value is less than alpha. Okay, remember that the alpha level is the room for error that we're given to make a mistake in our conclusion. We want to be under that threshold there. Okay, so we'll use a p-value method as well. The setup to do so is called ANOVA in the calculator. To find ANOVA in the calculator, go to Stat, Tests, and it's going to be the last function in the calculator in the test. So I typically like to hit up on the arrow key here to get me to the bottom of the list, but the ANOVA command will be down here. And when you hit enter here, it doesn't really tell you what to input for ANOVA. Same thing with the TI-83, you'll see this exact same screen here. So both calculators have this in common. So what ANOVA needs, once you have that, is it wants you to enter the populations into the parentheses. Okay, so Alaska we represented as L1, comma, Florida we represented as L2, comma, and then Texas we represented as L3. Now, because ANOVA testing can test 3 or more population means, if it's necessary, proceed with a comma L4, L5, however many populations you have, and then you close. Okay. So in the calculator, we'll go ahead and input second 1 on the keypad, comma, second L2 on the keypad, comma, and then second L3, 3 populations, we can close this. And we're looking to gather evidence as far as p-value goes, okay? Now, very similar to chapter 10, okay? There's a lot of information given whenever you conduct a test. The one of interest will be 2 numbers. The first number that you see here, capital F, this is called a test statistic, okay? And if you recall in chapter 10, MyMathLab will ask for the test statistic, and we'll proceed with giving it the value as is. So test statistic should be F naught, very similar to the previous tests. It should be F naught, but the calculator represents it as F. And again, we'll give the MyMathLab the value as is, okay? Once again, for us though, we're more interested in the p-value method. So p-value we have as 0.046. And what we need to do is we need to compare to alpha, where the alpha level is given as 5% level of significance. Okay. So once again, we're given 5% room to make a mistake in our conclusion. After conducting an ANOVA test, our ANOVA test is telling us that we have about a 0.046 chance of making a mistake. Here, keep in mind that we're underneath the threshold, okay? And if you're underneath the threshold, we reject the null hypothesis. We reject the null hypothesis. So what does that mean when you reject the null hypothesis? The null hypothesis says that the mean acidity level for Alaska is the same or equal as the mean acidity for Florida, which is also equal to the mean acidity of Texas. 3 different regions, 3 different populations. After conducting this test, we reject that null hypothesis. That means that at least one population mean is different. So 3 different regions, we have one mean acidity that may be different. So that gets us to our conclusion now. Okay, last step. Conclusion. So here, very similar to how we stated the conclusion in chapter 10, reject the null hypothesis, state your alpha level. Okay. By rejecting the null hypothesis, we have enough evidence to conclude. And then we repeat the alternative hypothesis that at least one mean is different.